our window onto the world. But a revolution is transforming television. Not what's on it, but what's in it. Welcome to the Plasma TV. To make plasma television super thin, you need to harness a fundamental cosmic force. The glass screen is filled with gas, but not... This may look like a normal television screen, but look closer and you'll see not one but two glass plates clamped together. It's what happens in between that is the secret to the production of the ultra-thin plasma television. Between the plates lies a matrix of 1 million individual and minute cells, each one a fraction of an inch tall. Across the top and bottom layers of the glass are hundreds of thin electrodes crisscrossing one another. Their job is to create an electric environment that charges a mix of inert gases that will soon fill up those cells. The gases are called neon and xenon. Once charged with electricity, they create plasma. Most people imagine there are only 3 states of matter: liquid, gas and solid. But there's a fourth, plasma. And believe it or not, it makes up nearly all the visible matter in our universe. By charging certain gases with electricity, it's possible to create plasma. And this plasma transmits light. So how do you recreate the northern lights inside a TV screen? First of all, fill it with neon and xenon. This tiny glass tube is fitted to the back of the screen by a robotic welding device. Using the tube, air will be sucked out and a gas cocktail will be pumped in. A short trip to an airtight section of the factory where the gas is stored. This is where chemistry meets engineering. The screens emerging from the chamber are full of gas, but there's one problem. Charged neon and xenon only generate ultraviolet light, invisible to the human eye. The solution? Another clever bit of chemistry. Each cell has been coated alternately with a red, green and blue chemical called a phosphor. So each pair of glass plates now contains a matrix of microscopic electrical wires and a honeycomb of minute cells, each filled with neon and xenon, and now delicately coated in various kinds of phosphorus chemicals. All that's needed to make the plasma do its stuff is the flick of a switch. This technician is creating a kind of electric storm right in front of our eyes. As an electrical charge surges around the components, the screens burst into life, and a plasma TV is born. This explosion of colored light shows the phosphors and the plasma are working. Now it's the job of the electrical circuits to combine the right cells to produce the right colors.
Plasma can identify 1 million colors. That's more colors than the human eye can recognize. I think plasma is a great technology.
But a TV that runs on gas with a little help from electricity poses peculiar problems. In a normal TV, you don't want faulty electrical circuits. In a plasma TV, you don't want a gas leak. So the screens visit the aging room. In here, hundreds of plasma screens are switched on and left for hours to make sure the chemicals are contained and stable. The plasma screen is working, but there are no pictures yet. There are no tuners, no receivers, no aerials. There's still a plasma TV to be built. Generating sound and vision involves thousands of individual components. Stored on reels of plastic, they're fired at high speed onto circuit boards. High-pressure plastic injection machines produce the various casings for the different sizes of plasma TVs made here. Then everything is brought together on the production line. Circuit boards which control the signal, the power, formats and tuners are all placed on the inner back wall of the TV. But right now the screen has a poor contrast ratio, giving off a kind of milky grey light. So another screen is added to increase the contrast. Then everything is checked again. Colour bars make sure each TV is producing the correct colours, whites and blacks, rather than muddy greys. Test patterns, formats and functions all need to be assessed. These guys at least get to watch the front of a TV screen. Spare a thought for Satoshi Maruono. It may sound like robotic bedlam, but to Satoshi's trained ear, the chirps and squeaks tell him if the TV's working as it should. And some tests involve a highly technical process.